everybody. Today we're going to be diving a little bit deeper into multiplication, specifically multiplying bigger numbers. I wanted to make sure that I show you all, not just with single digit numbers, but also multiple digit numbers, ways that you can come up with the answers to multiplication problems. The first way that I'm going to be showing you is partial products. Hope you guys enjoy. Take care. Right, here we go with partial product models. What I'm going to be doing is showing you two ways that you could solve this multiplication fact, 73 times 9, based on the ways that you can decompose these numbers. I'm also going to show you how to do a 3x1 digit problem and a 2x2 digit problem using the partial product model. Let's get started. First one that we're going to look at is 73 times 9. I'm going to decompose the bigger number, and I'm just going to do a simple decomposition. I'm going to break that 73 into the values of each place. And what I mean by that is this. Since there's a 7 in the tens place, 7 tens has a value of 70. And then since there is a 3 in the ones place, it has a value of 3. So I'm breaking or decomposing 73 down into 70 plus 3. Okay, now we're going to make a box that has those two digits. So I have 70 or 7 tens plus my 3 ones. I'm going to be multiplying both of these numbers by 9. What I found in teaching this particular method is the students have trouble keeping track of what to multiply with what. So what I do in this case is use highlighters. And what I mean by that is this. So both of these boxes would be multiplied by this 9. In this particular box, we're doing 9 times 70. And in this box, we're doing 9 times 3. This way, the students can keep up with what is being multiplied together. Now, they can follow the highlighting to see what is going to be multiplied in this box. In this case, I know it says 9 times 70, but really all we need to look at is 9 times 7. 9 times 7 is 63. I noticed that on one of my factors that I'm multiplying, there is a 0. So because there is this 1 0 here in 70, I know that 1 0 is added on to my amount to make 630. The next box, I'm going to multiply 9 times 3. 9 times 3. Again, using that highlighting to follow what digits to be multiplied in each box. Put that value inside of that box. What I do from here is basically take those partial products and combine them by adding. So 630 plus 27. 0 plus 7 is 7. 3 plus 2 is 5. And then 6 plus no hundreds is 6. So I get a final product of 657. Now, I wanted to do this again because you don't have to necessarily decompose just by tens and ones. You can also choose to decompose by friendly numbers. Let's say I may not know my 7s, but I know another way that I can still get 70 or 7/10 through decomposing in a different way. Let's say I did, instead of thinking of this as 7/10, I could break it down even more into 5/10 or 50 plus 2/10 or 20. I still get my 70 or 7/10, and then I would break this down into just 3. So I could decompose that number any way I want, whatever way I feel comfortable with, and still come up with the same solution. And again, I'm going to multiply this by 9. So let me set up my box. So I have 50 plus 20 plus 3. I'm still going to be multiplying that amount by 9. So just as I did in the last problem, all of these boxes will be multiplied by 9. In this box, I'm doing 9 times 50. In this box, I'm doing 9 times 20. And in this box, I'm doing 9 times 3. And this is all multiplication. So in this box, first box, I'm doing 9 times 50. But really, I'm doing 9 times 5. 9 times 5 is 45. And then I notice this particular factor has the 0, 1 0. So that means 1 0 goes onto my answer to make a product of 450. Okay, in the next box, I'm doing 9 times 20. But really all I need to focus on is 9 times 2. 9 times 2 is 18. But this 20 has a 0 on it. 1 0. So that means 1 0 goes on my answer to create a product of 180. And then 9 times 3, as we did in the last problem, is 27. So again, I just decomposed it a different way. Let's see if we still get the same product, or sum in this case. 450 plus 180 plus 27. So I'm combining those partial products. 0 plus 0 plus 7 is 7. 5 plus 8 is 13. Plus 2 is 15. 1 plus 4 is 5. Plus 1 is 6. So you still get that final product of 657. You're just decomposing in a more friendly way. 5s and 2s are much easier to count than 7s. So again, this is just another way to break it down more and come up with the same product. And I'm going to show you this model now doing a different type, a 3 by 1 digit. This one is 463 times 7. So for this particular model, I'm going to need 3 boxes for my first factor. Or decomposing, I'm going to be decomposing this into the values of the places. So 400, because that's what the value of a 4 in the hundreds place is. 6 tens is equivalent to 60, and 3 ones is equivalent to 3. So I'm going to be doing 400 plus 60 plus 3. I'm going to be multiplying each of those by 7. So when I think about this particular model, all of these will be multiplied by 7. All of these boxes will be multiplied by 7. in this particular box, the first box, I'm going to be doing 7 times 400. The next box I'm doing 7 times 60. And then the third box I'm doing 7 times 3. Still multiplying. So the first box, as you can see, has 7 times 400, but really all I need to look at is 7 times 4. 7 times 4 is equal to 28. And I do see that the 400 has 2 zeros. So that means 2 zeros need to go onto my answer to create a value of 2,800. The next box, 7 times 60. Really all I need to look at is 7 times 6. 7 times 6 is 42. And the 60 does have 1 zero, so I know that 1 zero needs to be added to that product to make. Last box is 7 times 3. That gives me a product of 21. So when I take those partial products and combine them, that's going to look like 2,800 plus 420 plus 21. That's going to give me, let's see, 0 plus 0 plus 1 is 1. 0 plus 2 plus 2 is 4. 8 plus 4 is 12. And 1 plus 2 is 3. So that's going to give me a total product of 3,241. This brings me to my very last problem or example that I'm going to show, which is 2 by 2 digit. The 2 by 2 digit problem that I'm doing is 85 times 26. So in this case, I'm going to need a 2 by 2 digit box. The reason why I need 2 by 2 is because I'm breaking this apart, or I'm decomposing this into the values of the places. 8 tens has a value of 80. 5 ones has a value of 5. So 80 plus 5. I'm also going to decompose 26. 2 tens has a value of 20. 6 ones has a value of 6. So I'm doing 20 plus 6. So these two boxes will be multiplied by 20. Oops. These two boxes will be multiplied by 6. These two boxes will be multiplied by 80. And these two boxes will be multiplied by 5. This is going to be important to keep up with where the highlighting is located. So again, I'm multiplying these. So in the very first box, if I follow the highlighting, that's 20 times 80, which really I can just look at 2 times 8. 2 times 8 is equal to 16. And then I see that the 80 has a 0, so that's 1. 20 has a 0 as well, so that's 2 zeros that are going to be added on to make 1,600. In the next box, we have 20 times 5. Really, we just need to look at 2 times 5. 2 times 5 is 10. And then 20 has 1 0, so I'm going to add 1 0 onto my answer to make a product of 100. In the next box, we're doing 6 times 80, which is really 6 times 8. 6 times 8 is 48. 6 times 8 is 48. And then since 80 has 1 0 on it, I know I add 1 0 onto my answer to make 480. And in the last box, I'm doing 6 times 5. 6 times 5 is 30. Neither of those have zeros on them, so I don't need to add any additional zeros. Now I just need to combine these partial products. So that's 1,600 plus 480 plus 100 plus 30. And when I combine those, 0 plus 0 plus 0 plus 0 is 0. 0 plus 8 is 8. Plus 0 is 8. Plus 3 is 11. 1 plus 6 is 7. Plus 4 is 11. Plus 1 is 12. And then 1 plus 1 is 2. So my final product would be 2,210. Here are my partial product models. Let me know what you guys think in the comments. Take care.